So for semester 2 of Algebra 2, we're going to be talking about what we call conic sections. And conic sections are different parts of a cone, and if we were to cut a cone, how we would get those. And so before we're going to start the conic sections, we're going to talk about lines. So we can talk about how we get from lines to conics. So a line is a straight path that goes on forever. Its equation is called a linear equation, and it can be graphed on the xy plane. And your equation of your line has always and will always be y equals mx plus b, where m is the slope, which determines how steep the line is, and b is your y-intercept, which determines how or where the graph crosses the y-axis. So if I wanted to make the line steeper, then I would increase the slope. If I decrease the slope, then the line gets less steep. So a steep line is going to be one that's almost vertical. A line that's less steep is going to be one that's pretty flat. If I make the slope negative, that changes the direction. So the line goes down from left to right instead of going up, so it looks like this. If I change the y-intercept, then all I'm doing is I'm changing the point where the line crosses the y-axis. In other words, I'm shifting it up or down. So a conic section is like a flat slice or a cross-section of a cone. And it is formed when a plane intersects a cone. So right here, I have a cone, or actually I have two cones that are on top of each other. And so if I were to cut the cone in different directions, I would get different shapes. So just so you have some idea of what these different parts of a cone are, what this is pointing to here, this piece, is called your base of your cone. The side on the left over here is called your edge. The other side, this over here and this here, are called your nap, N-A-P-P-E, N-A-P-P-E. And down here, where this is pointing, is again a base. And this point here that it's pointing to is called the vertex. So, depending on what intersects and where it intersects, different things are created. So, for example, if a plane, or a plane would be like a piece of paper, if it intersected at the when it's intersected at the vertex of the cone, it creates a point. So if you had a piece of paper that intersected right here, you would get a point. If a plane intersected the edge of a cone, then you would get a line. And this is the next part where we actually start talking about our conic sections. So if a plane intersects only one nap of the cone parallel to a base of the cone, you're going to create a circle. So what that's saying is, looking at these pictures that are drawn down here, where I have circle right here, if I were to draw a plane again is like a piece of paper. If a piece of paper were to come in and cut this cone right here, well, when I opened it up and looked at it, I would see a circle. That's what shape would show up. If a plane were to intersect only one nap of the cone and is not parallel to any part of the cone, then I'm going to create an ellipse. An ellipse is the mathematical word for oval. So what that's telling you is that if I had a plane, a piece of paper that intersected these cones diagonally, then when I looked at it, I would see an ellipse. If a plane cuts through both naps of the cone, but not through the cone's vertex, then I get what's called a hyperbola. A hyperbola is like two parabolas that either open up and down or they open side by side. And the way I get that is if I had a plane or a piece of paper that cut through the cones like this, vertically. Then what I would see when I took them apart would be parabolas looking like hyperbolas looking like that. I always like to think of it as a hyperbola is a hyperparabola, and there's two of them. And if a plane cuts through only one nap of the cone parallel to an edge of the cone, you're going to get a parabola. And that would be if I cut it like this. So notice that this line, the plane that I've drawn in, is parallel to the nap. And the way that I get a line, because that was the last picture we had to draw in there, the way we get a line is if we cut it here along the nap. Then I'm going to get a line. So all of these different shapes can be created from a conic, which is two cones on top of each other. This particular picture that you see on the screen here it's a better example of how these conic sections are cut because you can really see what happens. So if you'll notice the blue thing here, this is the plane. So when this blue plane is cut so that it is parallel to the edge, with this being the edge, I'm going to illustrate that in black. With this being the edge, so the plane is parallel to that. Then what you get is what you see here in yellow, and that would be a parabola. So when you cut this, you take the same plane and you cut it so that it's parallel to the base, this being the base, you can see that you get a circle. When you cut it so that it's not parallel to anything, but it goes through the two sides, you can see you get this ellipse here. And when you cut it so that it's vertical but doesn't go through the vertex, you get the hyperbolas. So hopefully this will help you better see where these pieces come from. So we're going to take some of this information that we learned, or all the information we learned rather, and actually utilize it for our question. So it says, which equation has the steepest graph? Well, recall the steepest graph means it has the biggest slope. And we're trying to decide what's the biggest slope. We ignore any negative signs. So we are just looking at the numbers. 2, 4, 1/2, and 5. So which one's the steepest? Well, that's going to be the one that's the biggest, and that's going to be y equals 5x plus 2. For number 3, if y equals 5x plus 1 is changed to y equals 2x plus 1, how would the graph of the new function compare with the first one? Well, we've got to figure out what changed. So it was 5x, now it's 2x. So my slope changed, and my slope decreased, which means that my line is going to be less steep. Now I'm going to do problem 6, so you'll have to do 5. If you wanted to shift the graph of y equals negative 5x minus 8 up, which equation could you use? So if I'm shifting it up, that means my number on the end, my minus 8, needs to increase. It needs to go up. So anything bigger than negative 8. Well, negative 8 is not bigger than negative 8. Negative 10 is not bigger than negative 8. Negative 1 is bigger than negative 8. And again, negative 8 is not bigger than negative 8. So y equals 5x, negative 5x minus 1 would be shifted up from negative 5x minus 8. Number 7. Which of the following is not a special type of conic section? Well, we have 5 answer choices, and the question is, which one did we not talk about in this section? Well, we talked about points, we talked about lines, we didn't talk about squares, we didn't talk about a pair of intersecting lines, we did talk about lines. I'm thinking that's probably not it. It is in fact a square. And lastly, number 9, what term describes the red curve shown below? So if you'll notice what this looks like, here's the red curve and here's the red curve. Well, when I draw this particular picture, what I'm getting is a hyperbola.